Hey everybody, this is Larry, this is Miko Q2 of the weekly contest 413. Cave nearest obstacle queries. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. I think this one is pretty much within interviewing scope. I would very much expect a problem like this on an interview or this difficulty, so definitely be very good at it, be very fast at it, be whatever you need to do with it. Yeah, I mean, anytime you want to get cave smallest, cave biggest, cave nearest, cave farthest, the first thing that should ring into your head, honestly, is heaps or are heaps. I don't know if I would call this pattern matching, but it is just the cleanest thing, right? I mean, there are other things with other solutions for sure, but you definitely should visit it, right? Maybe that you could do a case select or something like this, or case selection or whatever it's called, but that's very complicated, so I would definitely revisit this, right? And I don't really have much to say about this one. I think the thing that you have to, I don't know why they kind of was unclear about this until like the distance is at the very end, because this should be a, this I don't get why they do it this way, because this definition should be at the very beginning, because this is not the this is not the default definition of distance. But it doesn't really matter, actually, honestly. It doesn't matter if it's this distance or D2, right? Like the regular Euclidean two-dimensional distance, right? It doesn't matter because it's the same thing. It just changes minor implementation detail, but still a little bit wonky if you ask me. But in any case, yeah, it's just looked another way. It's just every time give me the cave nearest. So that means that you want to do, you want to keep track of the k smallest number, right? And that's basically the idea. And to keep track of the k smallest number on a running basis, you want a max heap, because you want to get rid of numbers bigger than your k smallest number. There are also other ways to do this, I guess, now that I kind of think about it a little bit. I mean, I jumped straight to the heap, but in a pinch, you can use a sorted list or some sort of, that kind of data structure, like a binary trees data structure, to get an answer in log n times instead of log k times. On this particular problem, I don't think it matters, maybe. Let me know in the comments if it's wrong, because I didn't try it that way. But I can imagine that on an interview, that's probably more like, like if I was the interviewer, I'd be like, hey, can you do a little bit better than, n log n or whatever, right? Or q log q, I suppose, where q is the number of queries. But yeah, nothing to it. This is as straightforward as a heap problem as it gets, honestly. It is top k, bottom k, k nearest, whatever is this, yeah. I mean, there are very minor twinkles, but that's about it, right? You have to append -1, otherwise, And if you have too many things, you pop. This magical line allows you to keep the query log k instead of log q, or log n if you prefer n is the number of queries, which I always find a little bit awkward. But yeah, it's gonna be. And so it's either n log n or n log k, and n log k is if you do this thing with the heap and getting rid of it. And that's pretty much it, really, right? So this is O of n, number of queries. You have 2 log k up to log k heap operation. So this is n log k. That's all I have for this one. Let me know what you think. I don't have much to add because, like I said, this should be pretty standard. It should be a basis of an interview. Like it's like a part of it. It won't even be that, the difficult part. So yeah. Anyway, that's all I have for this one. I got this one in about 2 minutes, which is actually a little bit slow, but I don't know. But that's all I have for this one. Thanks for watching, and you could watch me solve it live in the contest now. I have a helper there. Okay. Cave nearest obstacle from the origin. Okay. Cave nearest. So then now we have further away. So I mean it's a heap problem, but oh, it's x plus y, huh? So then do we want a min heap or max heap? Why am I so bad at this? Maybe I'm wrong on this one actually. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest or this problem or everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.